But the algorithm, every algorithm, is just this. That's all this is. An algorithm is a step-by-step procedure for solving a problem. It's a step-by-step procedure for solving a problem, and if it's a good algorithm, it's generalizable, which means you can create a procedure for solving problem X, and it also works for problem Y and problem Z, because you've identified some patterns or commonality or whatever. So Facebook has an algorithm. YouTube has an algorithm. The algorithm in YouTube is a step-by-step procedure for solving a problem. What's the problem that YouTube is trying to solve? How do I get Bill to watch more videos? Why? Because every time I watch a video, an ad pops up, and it wants me, if I watch more videos, then YouTube makes more money. That's the problem. The problem it's trying to solve is, how do I get people to watch more videos? So they have hundreds and hundreds of people that are thinking about this all the time. And the algorithm itself for that is very complex. But we know for sure that things that we search for, things that we click on, things that we watch more of versus videos that we watch 10 seconds of and leave, all of those things are part of that algorithm, such that if we do those things, you heavily influence the videos that it suggests that you watch next. Because what it's doing is it's trying to put stuff in front of you that you will be interested in, that you will want to watch. So that's the problem. And it's a generalizable algorithm, because the algorithm in YouTube isn't just geared for one person, one specific person out there. It's trying to figure out, how do I make millions of people or hundreds of millions of people watch more videos, right? So it's a generalizable algorithm. It's very complex, but we know some things about it, but based on how it behaves. If I create an account and log into YouTube and start looking at videos of monster trucks, in 30 minutes, I can have YouTube's algorithm trained so well that that's all it's going to show me. With an occasional video, because there's only a limited number of monster truck videos out there, occasionally it's going to show me another video. But what that other video is going to be based upon is other videos that people who like monster trucks watch frequently. So it's trying to branch me out into other areas that I might be interested in, right? So an algorithm, step by step. Let's look at a simple problem. If you are going to solve this, there's an algorithm for this. Like if you're doing it by hand, right? There's a simple procedure that you use to solve problems like this. What's the first thing I do here if I'm going to solve this by hand? 8 times 1, right? All right, 8 times 1, write the answer down. 8 times 3, right here, 248, right? And then what I do, 4 times 1, then 4 times 3, write it below that, but shifted one space to the left, and then I add them together, right? That's the algorithm for solving a multiplication problem by hand. And that will work no matter what numbers I put there, correct? Same algorithm, same steps. Same algorithm will solve this problem as well, will it not? Yeah. Exactly the same algorithm. Now, I do not want to do this problem, right? Because think about how many rows you're going to be adding up. The odds of me getting this correct are almost 0. Even though I know my basic multiplication, the odds of me making an error here somewhere are very, very high, just because of the size of this problem. Obviously, this would be an easy problem. If I feed this into a computer, I just multiply those two numbers together and I'm done. But the algorithm for solving this by hand involves the application of those same steps. So you're just going to start here, and you're going to multiply your way across, right? And then once you do all of those, you start the next one. And you just keep doing that until you're done. And then you add them together. Same algorithm. So that's a good generalizable algorithm, because anytime I want to multiply any two numbers together, no matter how big or small they are, that algorithm will technically work if I don't make mistakes, which I totally will. So the steps in creating an algorithm, when you look at a problem and you're like, how do I create an algorithm for solving this problem? That's kind of what we're doing in a lot of our projects so far. And it's going to become more so as we get into it. So there are 3 steps. The first step is deconstruction. What you're going to do during deconstruction is you're going to break the problem down into the most simple steps you can think of. Basically, you're going to break it down into such simple steps that each step by itself is too simple to break down any further. Then you are going to solve each one of those little steps that you broke it down into. And presumably, each one of those is simple. For this, right? Can anybody add these 2 numbers together in their head? Maybe somebody, if you have enough Tylenol in your youth, I guess. Right? So, if you can do that in your head, good for you. Most of us cannot. But what this problem involves is breaking it down into the most simple steps, right? 8 times 4 we can do in our head. So we break down those numbers. Next, we solve each thing. And then next, we put it back together. And that's what we're doing when we add all of those rows underneath it. We're reconstructing the answer. So rather than looking at this and saying, I'm just going to try and solve that, we're going to break it down into little pieces that are easily solvable. We're going to solve each one of those little pieces, and then we're going to put it back together.